Hello everyone, in this video we will solve this exercise that solves a function which is a polynomial. Study the limits, find the derivative, line of symmetry, equation of a tangent, inverse function, and derivative of an inverse function. Now consider the function defined over R by f of x is x squared minus 3x minus 4. C is representative curve in an orthonormal system. Study the limits of f at negative infinity and positive infinity. Now part 1, we will study the limits at negative infinity and positive infinity, which are the endpoints of the domain. F of x is a polynomial, it's clear, is a polynomial. The domain of f is minus infinity plus infinity. Now the limits of a polynomial depend, as we have explained in previous videos, depend on the polynomial having the highest exponent. So the limit at infinity, as x tends to negative infinity, of f of x is equal to the limit of x power 2, which is positive infinity, and the limit as x tends to positive infinity of f of x is equal to the limit of x squared as x tends to positive infinity, which is also plus infinity. Now this is part 1. Part 2, find f prime of x and set the table of variation of f. F prime of x is equal the derivative of x squared minus the derivative of 3x minus the derivative of 4. So the derivative of x squared is 2x, the derivative of minus 3x is minus 3, and the derivative of negative 4 is 0. To study the table of variation, you set f prime of x 0, so 2x minus 3 is 0, x equals to 3 over 2. This is the table of variation. Here is x, f prime of x, f of x, x from negative infinity to positive infinity, and here 3 over 2. Let's find f of 3 over 2. F of 3 over 2 is 3 over 2 squared minus 3 times 3 over 2 minus 4, 9 over 4 minus 9 over 2 minus 4, which is 9 minus 18 minus 16 over 4. It is 9 minus 18 minus 16. 9 minus 18 is negative 9, negative 9, negative 16 is negative 25 over 4. So minus 25 over 4. Okay. Here f prime of x is 0, so minus plus at negative infinity. F of x is positive infinity. At positive infinity, f of x is positive infinity. So f of x decreases from plus infinity to minus 25 over 4. Then it increases from minus 25 over 4 to plus infinity, and this is the table of variation of f. Verify that the straight line dx equals 3 over 2 is a line of symmetry for the curve C. In general, in order to verify that a line x equals a is a line of symmetry, you need to verify that f of 2a minus x is equal to f of x. X here is equal to, a here is equal to 3 over 2. So a here is 3 over 2. So let's verify that f of 2, 3 over 2 minus x equals to f of x. F of 2 times 3 over 2 minus x is equal to f of 3 minus x, which is equal to 3 minus x squared. This is f of x squared minus 3x minus 4. Instead of x, we will substitute 3 minus x in order to find f of 3 minus x. Minus 3 into 3 minus x minus 4. Now let's calculate it. This is a perfect square. 3 minus x squared, it's a squared, so 9 minus 2 a times b minus 2 3 times x plus b squared, so plus x squared, minus 3 times 3 9 plus 3x minus 4, which is equal to x squared. Here this is minus 6x. Minus 6x plus 3x is minus 3x. 9 with minus 9, so minus 4. If you look at f of x, you will find that this is equal to f of x. So verified, x equals to 3 over 2 is a line of symmetry of C. Now part 4, solve f of x equals to 0 and interpret the result graphically. F of x equals to 0, so x squared minus 3x minus 4 equals to 0. Using trial and error, two numbers, their product negative 4 and their sum is 3, is negative 3. X minus 3, x plus x minus 4, x plus 1. So x minus 4, x plus 1 is 0, minus 4x plus x is minus 3x. So this means x equals 4 or x equals to minus 1. Graphically, what does this mean? This means that the graph of f C will intersect the x-axis at 4, 0 and at minus 1, 0, because when x is equal to 4, f of x is 0 means y is 0, and when x is negative 1, f of x is 0 means y is 0. So the graph intersects the x-axis at 4, 0 and at negative 1, 0. Write the equation of the tangent t to c at the point of abscissa x equals 4, and then study the relative positions of c and t. Now at x equals 4, and from part 4, f of x equals 0. So to find the equation of the tangent, this is the equation, general equation of the tangent at point AB, f of x minus f of a is equal to f prime of a into x minus a. F of a is b. So f prime we need to find f prime of x. F prime of x is 2x minus 3. So f prime of a is 2 times 4 minus 3. So it's 8 minus 3, it is equal to 5. Now the equation of the tangent is y minus 0, b is 0, f of a is equal to 5 into x minus 4. So y equals 5x minus 20. This is the equation of the tangent at the point of abscissa x equals 4. Now to study the relative positions of c and t, you need to find f of x minus y, where y is the equation of the tangent. It's equal, this is f of x, x squared minus 3x minus 4 minus 5x minus 20. So it is x squared minus 3x minus 4 minus 5x plus 20, which is x squared minus 8x plus 16. Now x squared minus 8x plus 16 is x minus 4 power 2, which is greater or equal to 0. So f of x is always above the tangent. The curve C, the graph of f of x, is always above the tangent t, except at x equals 4, C and t intersect. At x not 4, C is above t, since f of x minus y, the equation of t, is greater than 0. Calculate f of 0 and then trace c and t. I'm not going to trace t, it's easy. Now let's calculate f of 0 and trace c. F of 0, so this is part 6, f of 0 is equal to 0 squared minus 3 times 0 minus 4. So f of 0 is negative 4, which means that the curve will intersect the y-axis at negative 4. Also, we have that the curve passes through the 2 points, negative 1, 0 and 4, 0. So here you have 3 points where the curve passes. We go to f prime of x. It's 2x minus 3 to see the minimum or maximum. So if f prime of x is 0, x is 3 over 2. F of 3 over 2 is equal, this is calculated before, 3 over 2 squared minus 3 times 3 over 2 minus 4, which is 9 over 4 minus 9 over 2 minus 4. It's 9 minus 18 minus 16 over 4. It's negative 25 over 4. Now, when x is negative infinity, f of x is positive infinity, it has a parabolic branch parallel to the y-axis. Also, when x is plus infinity, f of x is plus infinity, it has a parabolic branch parallel to the y-axis. At x equals 3 over 2, we have f prime of x equal to 0 and f of x negative 25 over 4. So f prime of x is negative before 3 over 2 when x is less than 3 over 2, and positive when x is greater than less than 3 over 2. So the function will decrease from plus infinity to negative 25 over 4 and increase from negative 25 over 4 to plus infinity, passing through this mode. So as you can see, a parabolic branch parallel to the y-axis, then the function decreases and passes through the point minus 1, 0, passes through the point 0, negative 4. It has a minimum at 3 over 2, negative 25 over 4. Then it increases to pass through the point 4, 0. And this is the graph of C. This is the graph of the tangent. It's easy, you may draw it alone. Show that over 3 over 2 plus infinity f admits an inverse function f minus 1. When does a function admit an inverse? A function admits an inverse if it is continuous and monotonic. Now here f of x is a polynomial, so it is continuous. So f is continuous. And over 3 over 2 plus infinity, if you go back to the table, you will find that f is strictly increasing, so monotonic, strictly increasing, which means that f admits an inverse function f minus 1 over 3 over 2 plus infinity. Now, as for the domain, as x equals 3 over 2, f of x is equal to negative 25 over 4. And as x tends to plus infinity, f of x tends to plus infinity. The domain of f minus 1 over 3 over 2 is the range of f over 3 over 2 plus infinity, which is, so d f minus 1 is f minus 1 of 3 over 2 plus infinity. It will not change the order since the function is increasing, which is equal to negative 25 over 4 plus infinity. Now calculate f minus 1 of negative 4. This is part 8. From previous parts, f of 0 is equal to negative 4. This means that f minus 1 of negative 4 is equal to 0. As for the derivative, f minus 1 of negative 4. Now, if the curve passes through a point AB, then f minus 1 prime of B is 1 over f prime of A. Now here C passes through 0, negative 4, which means that f minus 1 prime of negative 4 is the reciprocal of f prime of 0. So all what you have to do is finding f prime of x, which is 2x minus 3. F prime of 0 is negative 3, which means that f minus 1 prime of negative 4 is negative 1 over 3. Consider the function g defined by g of x is 3 over 2 plus radical 25 over 4 plus x. Calculate or find f round g of x and g round f of x. Now, this is part 9, by the way. Let's find f round g of x. F round g of x is f of g of x. So in the place of x, we will substitute g of x, or we will replace x by g of x. So f of g of x is, this is f of x, is equal to 3 over 2 plus radical 25 over 4 plus x squared minus 3 into 3 over 2 plus radical 25 over 4 plus x minus 4. This is square the first, 9 over 4, plus 2 first by second, 3 radical 25 over 4 plus x, plus the second square, 25 over 4 plus x, minus 3 into 3 over 2, 9 over 2, minus 3 radical 25 over 4 plus x minus 4. Now, this cancels this. 9 over 4 plus 25 over 4 is, we will have 9 over 4 plus 25 over 4 minus 9 over 2 minus 4 plus x. This is 9 plus 25 over 4 is 34 over 4 minus 9 over 2 is 18 over 4 minus 16 over 4 plus x. 34 minus 18 is 16, minus 16 over 4 is 0, so the result is x. So f round g of x is equal to x. Now let's find g of f of x. G round f of x. So in the place of x, we will replace it by f of x. So g of f of x is equal to 3 over 2 plus radical 25 over 4 plus x squared minus 3x minus 4 3 over 2 plus x squared minus 3x 25 over 4 minus 16 over 4 is 9 over 4. So this is 3 over 2 plus x minus 3 over 2 radical squared. So it is 3 over 2 plus x minus 3 over 2, which is equal to x. Why? This is x minus 3 over 2 squared is x minus 3 over 2 over 3 over 2 plus infinity. So this is positive. So it gets out of the radical as x minus 3 over 2. So here we move to part B, deduce the expression of f minus 1 of x. Now since f round g of x is equal to g round f of x is equal to x over 3 over 2 plus infinity, g of x is equal to f minus 1 of x. In general, if f round g is equal to g round f is equal to x, this means that g is the inverse function of f and f is the inverse function of g. So the expression of f minus 1 of x is 3 over 2 plus radical 25 over 4 plus x.